Okay, here's a video solution for problem 4.7. Okay, in this problem, we have an aircraft that has a glide ratio of 12 to 1. Okay, so that's part of our given. Okay, and then we know that we have a building that's 45 meters high. And it's right below the glide path. Okay, so if the airplane clears the building by 12 meters, which seems shockingly low to me, but we'll just go with that. Okay. Plane clears the building by 12 meters. Okay. And what we're trying to find is how far from the building does the plane land. Okay, so that's the format I'd like you to use for the exam. Okay? All right, so what's next is you need to draw a picture of what's going on. Okay, so we can have a picture and we say here's the building. Okay, so we know that's going to be 45 meters high. And then another 12 between here and here. We have another 12 meters. And that's how high it is when it clears the building. Okay, so this plane is dropping at a glide ratio of 12 to 1. It's coming down and landing. Okay, so if you think about it, we have a triangle. Okay, it makes this triangle, and we want to know this distance d. Okay, so we want to find d. All right, and so what we have is this length, which is the sum of 45 and 12. Okay, so we can add those together and we would get that to be 57. Okay. Now, the question is, do we have enough information to get this? If we had this angle theta, wouldn't we be able to get the tangent of theta is equal to the opposite over the distance d? Okay, so all we need is the tangent of theta. Well, don't we really know that? Because this slope here has a rise of 1 for every run of 12. That's what glide ratio means. So that's the slope of that line. Okay. All right, so we don't really know the exact distance out here, but we do know this ratio. And so the ratio is what gives you the tangent of the angle. So tan theta is the opposite, which is 1, divided by 12. Okay? So that lets us find theta. I mean, we don't need to find it because here's tangent of theta. We plug this in here, and we have that 1/12 is equal to 57 over d. We can solve for d. Do I did that wrong. I'm sorry. We can solve for D. Yeah. And we get number 684. Okay, looking at this, looks like we have 2 significant digits in this problem. Okay, whenever someone gives you a ratio and there's the number 1, ratios are often reported as something to 1. So if it had been 1 significant digit, this would have been a 10. Okay, so 1 does not drive the significant digit determination in this problem. Okay. All right, so we solve for D. We report that to 2 significant digits, and we get 680. Okay, put a box around our answer. And this is in meters. Okay, we should carry these units through. Okay, so there's the solution to 4.7.